Hello, this is Spoorthi from Aerobee section. My topic for concept video is sample space events of a random experiment. Random experiments. Let's say that you toss a fair coin, not a prank coin. There are only two possible outcomes, a head or a tail. Also, it is impossible to accurately predict the outcome, head or a tail. In mathematical theory, we consider only those experiments or observations for which we know the set of possible outcomes. Also, it is important that predicting a particular outcome is impossible. Such an experiment where we know the set of all the possible results but find it impossible to predict one at any particular execution is a random experiment. Even if a random experiment is repeated under identical conditions, the outcomes or results may fluctuate or vary randomly. Let's look at another example. You take a fair dice and roll it using a box. When the dice lands, there are only six possible outcomes that are 1, 2, 3, 4, 5, and 6. However, predicting which one will occur at any roll of dice is completely unpredictable. Types of events. In a random experiment, the following types of events are possible. Those are simple events, compound events, equally likely events, mutually exclusive events, exhaustive events, independent events, and dependent events. Let us talk about simple and compound events. Simple or elementary events are those which we cannot decompose further. For example, when you toss a coin, there are two possible outcomes, heads or tails. The event that the toss turns up a head is a simple event, and so is the event of it turning up a tail. Similarly, when you roll a six-sided dice, then even that number 3 comes up is a simple event. The compound or composite events are those which we can decompose into elementary or simple events. In simpler words, an elementary event corresponds to a single possible outcome of an experiment. On the other hand, a compound event is an aggregate of some elementary events, and we can decompose it into simple events. To give you some examples, when you toss a fair coin, the event turning up of a head or a tail is a compound event. This is because we can decompose this event into two simple events. The first one is turning up of the head, and the second one is turning up of the tail. Similarly, when you roll a six-sided dice, the event that an odd number comes up in the component is because we can break it down into three simple events. That is, number 1 comes up, second is number 3 comes up, and the third odd number 5 comes up. Equally likely events. If among all possible events, you cannot expect either one to occur in preference in the same experiment. After taking all conditions into account, then the events are equally likely events. Let us see some examples of equally likely events. Back to our favorite coin. Tossing a fair coin has two simple events associated with it. The coin will turn up a head or a tail. Now, there is an equal chance of either turning up, and you cannot expect one to turn up more frequently than the other. Also, in the case of rolling a six-sided dice, there are six equally likely events, mutually exclusive events. In a random experiment, if the occurrence of one event prevents the occurrence of any other event at the same time, then these events are mutually exclusive events. Some examples of mutually exclusive events are when you toss a fair coin, the turning up of heads and turning up of tails are two mutually exclusive events. This is because if one turns up, then the other cannot turn up in the same experiment. Similarly, when you roll a six-sided dice, there are six mutually exclusive events. Remember, mutually exclusive events cannot occur simultaneously in the same experiment. Also, they may or may not be equally likely. Example of dependent event. Let's say that event is drawing a queen from a pack of 52 cards. When you start with a new deck of cards, The probability of drawing a queen is 4 by 52. However, if you manage to draw a queen in one trial and do not replace the card in the pack, then the probability of drawing a queen in the remaining trials becomes 3 by 51. Dependent events. Two events are dependent if the outcome of the first event affects the outcome of the second event. Example, if I take a marble out of the jar and don't put it back in, I change the probability of the next pick. Independent and dependent events. Independent events. Two or more events are independent events if the outcome of one does not affect the outcome of the other. For example, if you toss a coin twice, the result of the second throw is not affected by the result of the first throw. In case of dependent events, if two or more events are dependent events, if the occurrence of non-occurrence of or non-occurrence of one in any trial affects the probability of the other events in the other trials. Sample space. The sample space of an experiment is a set of all possible outcomes of the experiment. Going back to our coin, the sample space S is equals to head comma tail, where H is heads and T is tails. Similarly, when you roll a six-sided dice, the sample space is S is equals to 1, 2, 3, 4, 5. Every possibility is a sample point or element of the sample space. Further, an event is a subset of the sample space and can contain one or more sample points. For example, when you roll a dice, the event that an odd number appears has three sample points. Thank you.